Hi everyone. In today's lesson we're going to be looking at what is meant by piecewise functions. So in your notebook, please put down today's subtitle, which is Piecewise Functions. As the subtitle suggests, piecewise functions occur in pieces. More specifically, a piecewise function is a function that is a combination of two or more functions, and that is why it's called in pieces. And additionally, each of those pieces or functions occurs inside its own domain on the Cartesian plane. Here's an example of how a piecewise function is written. Notation-wise, in this example, the piecewise function f of x equals, and you mark down the three different pieces or functions that make up f of x. In this case, f of x is made up from 2x plus 1, x squared minus 1, and 3x minus 2. Three different functions, kind of like puzzle pieces, that make up one huge piecewise function called f of x. The piecewise function f of x is not just one rule. It is all three rules, and the rule that you use depends on where you are in the domain. The function 2x plus 1 represents f of x if the domain that you're investigating goes from negative infinity all the way to negative 1, including negative 1. The second rule, x squared minus 1, represents f of x if the domain under investigation is from negative 1 to 5, not including negative 1, but including the 5. And finally, the third rule, 3x minus 2, represents f of x if the domain under investigation goes from 7 included all the way to positive infinity. And as you can try and visualize, the piecewise function f of x graphically will look three different styles within those three different domains. The first and the third rules are both linear, and the second rule is quadratic. In normal functions, one of the most common procedures that you perform is to calculate the numerical value of a function given an x value. Well, for piecewise function, the same procedure can be performed. The only difference is that when calculating the numerical value of a piecewise function f of x, we have to pick the correct rule to use depending on the interval in which x is located. Here's a very quick example of how to calculate the numerical value of a piecewise function. Suppose I give you a piecewise function f of x is defined by two rules. The first one, a linear one, 5x minus 2, is the rule of f of x only if the x goes from 1 to 3, including the 1 and the 3. The second rule is quadratic. X minus 3 all squared plus 1 is the rule to be used only if x is located between 5 and 10, including the 5 and the 10. So, with the piecewise function in front of us, let's calculate the numerical value of, let's say, when x equals to 2. Now, ask yourselves, when x equals to 2, which interval is it located in? Well, the 2 is located in the interval 1 all the way to 3. Therefore, the rule associated with that interval is the linear one, 5x minus 2. So we have to use the linear one to calculate f of 2, which gives us 5 multiplied by 2, subtract 2, which equals to 8. Now suppose we calculate the numerical value of f of x when x is 6. Now for this particular x value, 6, it is located in the interval 5 all the way to 10. And that interval is linked to the quadratic function x minus 3 all squared plus 1. So that is a rule that we have to use when x is 6. So plugging in 6, we get 6 minus 3 all squared plus 1, giving us a final value of 10. So as you can see, calculating the numerical value of piecewise functions is extremely easy. The only thing that you have to be careful of is making sure you match up your x value with the correct interval, which links up to the correct rule to use. And that's all there is, ladies and gentlemen, to your introduction of piecewise functions.